Okay, so the next thing that you're going to do is determine the area of the, not the area, excuse me, the height of the light pole. This is kind of cool actually. So I'm going to zoom out. I'm actually going to crop this image. This is copied that image over. I'm going to crop it because I don't need all this. So I'm going to crop it down so I just have what I need. What I need is the full length of the tennis court. I need the light pole and its full shadow, and I need the fence post and its full shadow. I'm going to have to set a new scale. Now that I've changed the image, I'm going to set a new scale. I'm just going to move my rectangle back over here and make sure that it's the full length of the tennis court. And just like you did before, I'm going to say 1 inch is equal to so many meters. You'll need to figure out the length of that line and determine what is the scale. And then you're going to measure the height of this shadow and, or excuse me, the length of that shadow and the length of this shadow right here. Now we can't determine the height of that telephone pole, that light pole, because the perspective's all wrong, but we can use the shadow, which is viewed perpendicular from a line going from the drone down to the ground. I can find the length of that shadow and combine that with the angle of the sun in order to find the the height of the pole. Let me draw a picture for this, which I think I have. So imagine that this is the light pole, a sort of a light pole, and then there's a shadow out here. Um, I know the length of this shadow. I'm going to call it X. And I want to find out what is this angle. That's the angle of the sun. Okay, and if I know what that angle is, then I can determine what is the height of that light pole. Remember our trig functions, SOHCAHTOA. That is, in this case, I'm going to have the height that's going to be the opposite and the adjacent. So that's going to be using my tangent function. The tangent of alpha is equal to opposite over adjacent. That is that the tangent of alpha is equal to h over x. So h then is going to be x times tan of alpha. Now I can get x, I can get that from my aerial image using my scale, measuring the length of that shadow, and then I can determine x. But I need to figure out what is alpha. In order to do that, I'm going to go back because I have a measurement for the height of this pole right here. For this pole right here, I have a measurement of its height. You're going to take this image that you found, you'll put it in PowerPoint, measure the length of this image, the length of this image, and create a scale so that you can determine what is the height of that image, like you did before. I'm going to leave you to sort of figure that out. So you want to know what is the height of that pole, and then once you find out the height of that pole, then I can go back to where I'm doing these calculations. Sorry, y'all. Okay, so this is for the light pole, but if I imagine I have my fence post right here, which I know the height of this, I know the length of the shadow, and so I can determine what is this angle. And so I say that the tan of alpha is equal to opposite over adjacent, or h over x, and then I can solve that for tangent. Of course, I have to take the inverse tan, so it's going to be the inverse tan of h over x. All right, so you solve for the angle theta, that's the angle of the sun, but it's the same for the fence post and for the light pole, and then I can take that and I can put that back in here to determine what is the height of that light pole. Now I want you to get that, you now have the height of the light pole from the aerial image. That's a common way to determine vertical heights from aerial images, but now I want to be able to compare it with something else. So that's why we come back to this last picture that we took, uh, which is the picture of the light pole. Just like you did for the fence post, you're going to measure the height of the light pole in PowerPoint, use a rectangle and figure out how many inches it is, and then set your scale using the meter stick that was in that same image. So just like you've done before, using your known distance, in this case the meter stick, to set the scale for that image, and then use that scale to determine the height of that bigger object, which in this case is the light pole. Report your percent difference on those two measurements.